Today we're going to start talking about a few more numbers and some graphs and a little bit more vocabulary, of course, because we haven't had enough of that yet. And of course, I'm going to start off talking about candy because I love candy. The biggest weakness of mine is candy. So here's a list that you have on your sheet there. While I'm writing this up there, I want you to think, if you had to choose one of these, which one would you choose? Yes. You only get to choose one, sorry. You have to choose one and only one of these categories. And I'm going to do the first column here, only the frequency. You already have all this. So everybody ready for their first choice? Their only choice? It's a hard decision for some of us. Now, if I had lots of time, I would maybe start over here and go one person at a time and say, okay, what's your choice? What's your choice? You could each tell me. And then I would count how many of you chose Reese's, how many of you chose Skittles, so forth. But that's a little bit time consuming. Let me ask you a question. Are you going to give me categorical or quantitative variable when I ask you this question? Categorical, right? You're all picking a category. I'm actually going to count how many are in each category, but the answer is a type of candy or none if you don't eat candy. So let's go through and do this. Everybody gets to vote only once and has to vote once. How many of you choose M&M's plain? Keep your hands up while I count, please. 1, 2, 3, 4, 5, 6, 7. How about peanut? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Skittles? Popular today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Reese's Pieces? 1, 2, 3, 4, 5, 6, 7. Did you guys see it? Have you seen the new one where they put the Reese's Pieces inside the peanut butter cup? I just saw that commercial this weekend. Oh, it looks so good. And how many of you don't want any candy? All of you eat candy? We do. Good for you. Okay, not really. It's not good for you. Sometimes you need a little. And all of those are my choice depending on my mood. You know, sometimes you want chocolate, but sometimes you need Skittles. It just kind of depends, right? Anyhow, okay, so what we just did is I essentially asked each of you a question. What's your candy? Which one's yours? And so forth. And then I counted them, and I put those numbers in the frequency column. Frequency just means how often did that answer show up. So if I had asked you individually, 7 times somebody would have said M&M's plain. And 11 times somebody would have said M&M's peanut. Let me close this door. Frequencies are sometimes helpful, sometimes it's not as useful. Example, if, let's say I ask all Americans some question about candy, and I can tell you that 7,983 of them chose Skittles. Well, that's a nice big number. But it's nice to know out of how many. To know how compared to all the other categories. So what we do is we change these into percents, and that's what we mean when we talk about relative frequencies. That's the next column on here. Relative frequencies. Turn them into percents. So now we have a review question. 7 of you said you like plain M&Ms. How do I turn that into a percent?
Out of 100?
Yeah.
And then divide, you said peanut runs, you said?
I think I said plain. I might have said peanut. I meant the first one.
You said 7 divided by.
So she says, so I heard a couple things. So she's over here telling me first I have to add up how many there are here. Somebody else said out of 100. They're both accurate in a sense, but the first thing is we need to know 7 out of how many. So we have to know the total even though I didn't ask for it. You cannot find relative frequencies without finding the total. So I'm assuming that you guys can add or your calculator is nearby. See if we can find this total. 1839? Is that right?
Yeah.
Yep.
We've got some people missing. There's a lot more on my roster. Did everybody vote? Well, no, it makes me nervous. Okay, we'll say it's 39. Okay, so the total's 39. So 7 out of the 39 said they liked plain M&Ms. So to turn that into a percent, kind of going back to our review from the first day. What would we do? She's already told me once. Somebody else know what to do? Turn that into a percent?
Divide 7 by 39.
Divide 7 by 39, right? I'm just going to put it off to the side right now here. 7 divided by 39, that becomes a decimal of some sort. Hopefully somebody has their calculator out. Can you tell me what that decimal is? Before you round, please.
17.94.
And some more after that? Yeah. It keeps going, but she gave me the first 4 digits. So when we divide, that's what we get. If we want to turn it to a percent, we reviewed this, remember, last week? Seems like forever ago. We want to turn that into a percent, we move the decimal over 2 places, or you multiply by 100. So if we did that, it would be 17.94%. And then, I heard you say 18%, both of you said that. We have to make sure we're clear on what the directions are in terms of rounding. If this problem is on, say, my stat lab for homework tonight, it will say, give me the relative frequencies, and it might say round to 1 decimal place. That always means round to that many after the decimal. So if they did say round to 1, my answer would be 17.9%. If it said round to the nearest whole number, then I'd go with your 18. So make sure, there's always a little blue box, underneath the directions on the MyStatLab. It tells you where it wants you to round. So I'm going to leave it at 17.9%. Questions on how I got that? Now, what about the out of 100 comment that I heard? It plays in here somewhere. If I had 100 people, 17.9, almost 18 of 100 people would have said they liked plain. If we were talking about counting people, we would have to round and say, if we had 100 of you, 18 would have said that. That's what a percent is telling us. What would it be out of 100? Everyone all right with that? You know how to get the rest of them? I'm going to let you get the rest of them. Always have your calculator out when you're in my class, by the way. I'll ask you to do this quite a bit. Let's see if you can get them. Fill in the rest of that table, the relative frequency column. And round them all to the 10th place, 1 decimal place, please. If you're not sure what to do, ask your neighbor or raise your hand. Or both.
Did you say round to the 10th?
To the 10th place, yeah, just like we did here. If the directions, if I haven't told you where to round, usually you can choose to round wherever you'd like. I know when you're online with online homework, it tells you where it wants you to round, so it knows how to grade you accurately.
Super specific.
It is. You learn real quick to read those directions to make sure that you're, because what happens is you're usually right, but then you don't read those directions and you get it wrong for the wrong reason. Some of us are quicker at dividing than others. So let's fill the rest of these in. What about for peanut M&Ms, what do we get? 28.2?
Yeah.
And Skittles? 35 point what?
9.
35.9%? Oh, same thing, I should have been able to handle that. I can get the last one too. Questions on where those numbers came from? Let me ask you a question. What should those numbers add up to? They should add up to 100%, because everybody got counted in there somewhere, so they should add up to 100%. Even though you're not asked to do that, I always recommend adding all of these to make sure they add up to 100%, because if they don't, you know you made a mistake somewhere. A quick way to find that you made a mistake. So if we add those all up, what did you guys add? I think I see what it adds up to. Tell me if I'm wrong. I think it only adds up to 99.9%. Where'd the other 0.1% go? Yeah, you know, because we rounded everything, it's quite possible that we're not gonna get exactly 100. I wouldn't have been surprised if it was 100.1, 0.1 over, 0.1 under, or it could have been exactly 100%, and that's just because we were rounding. I'm not too concerned it wasn't exactly 100. If it's off by anything more than that one little decimal place, I'd be worried. Something happened wrong, I did a wrong calculation, we'll fix it. When you're doing relative frequencies, sometimes they don't make them percents, they leave them in decimal form. Like they would have listed all these numbers, 0.1794, 0.282, and then the next step they ask you to turn them into percents. Again, it's reading the directions on the MyStatLab. I'll take them either way if I ask for it, but the MyStatLab is very picky about which way it wants them. So frequency is just how often it shows up. Relative frequency is in percents, because now you can actually compare the categories. And you can say more than a third of the people chose Skittles. A third is 33.3%. Now that I have the percent, I can really see that it's more than a third. Just telling you 14 people chose Skittles, it's kind of tough to see what that means, but it's more than a third. The same number chose here and here, you could have seen that already. But percents kind of help us compare things a little bit better. Okay, so the last column is cumulative frequency. It's not real helpful in categories, in categorical data. It's more helpful in quantitative, which we'll see, but we're still going to talk about it so you know where it comes from. Cumulative, make sure you're writing down these notes on how we're finding these. Cumulative. Starts off with the number in the first category, and that number just gets brought over here. And then it's everything in this category and this one combined. So I had 7 people chose plain M&Ms, 11 people chose peanut M&Ms, so combined, I had 18 people choose both these categories. So we're just adding those together. So this number here is 18. I got that by adding the 7 plus the 11. And then the next one down will be, okay, how many people chose these 3 categories? So I would need to know these 7 people plus these 11 plus these 14. So I would take that 14 added to my 18 I already had. So do you have looks on your faces that make me think there might be a question? Question on where these are coming from? So 32 people chose one of the first 3 categories. That's all that means. And then the next one would be adding this 7, that would be 39. And then adding the 0, still 39. Notice that this number and this number are the same. They better be. 39 was our total number of people. 39 is the number of people that chose this category or one of the ones above it, which is all of our categories. So there better be everybody in there. So that's where we use cumulative. I didn't bring any candy, sorry. Have you seen all the new flavors of M&M's too? There's so many new ones. The caramel, oh, love those.